now, and the symbology that I had created before explains what mass does as it travels past this barrier here into the speed of light barrier, right? Um, so now we have to figure out what's inside mass, and I'm talking about the constituents of mass, not protons, neutrons, and electrons. But that's a good start. Protons, neutrons, and electrons. Positive, neutral, negative, which are atomic structures inside mass. Now, of course, you've seen the atomic structures from school. Now they're absolutely wrong, so it's time to evolve, but I don't know if they're being taught the new ones in school today. Um, Nevertheless, so once you knew that inside mass were these things, then you know, most of us do, that they get smaller and smaller, smaller particles, and smaller and smaller and smaller and smaller. So one thing is for sure, as you look inside mass, look inside matter, you start to see particles, and the particles have particles inside of them, sort of like those Russian dolls that have a bunch of dolls inside of one another, right? So it's similar to that, how mass is. So because of this, then I thought to myself, well, if it gets small enough, then you would get a reverb to the point where it collapses and then pushes out again, right? Because it would get too small. So I looked into that. Turns out there is something that can't go any smaller than what it is, and that's called a Planck. In fact, invented by Max Planck, who discovered it. Max Planck, named after him, is called the Planck's length. And he discovered that this length is the shortest distance in the universe. That particles don't, actually at the time, they didn't know it was a particle. Now they do, because things have evolved due to my stolen work. But, okay, so we have a Planck's length. Max Planck discovered it by finding out a deduction in frequency waves. He just took the frequency waves and deduced them and realized that there was a point that they could not go beyond, and that was called the Planck's length right there. Okay. All right, so we have the smallest length in the universe called the Planck's length. Extremely smaller than any of these. So small. Okay, so we have the Planck's length. So, with that in mind, I went back to the symbology, and we have a Planck's length now. Planck's length, if you take it end upon end, like this, then we just created that again, which goes off into infinity. Okay? Positive repulsive force. And thus, I just did the same thing. So we have a negative force of the Planck's length. So smallest length in the universe, in an exponential infinite that goes on forever, and a negative force that has to be equated, which is a deduction factor. And if you want to see if mass actually does this, well, just look at any sun. Because the theory alone already explains all of this from where I'm at right now. I went further, but so you have a sun, right? So if you do it like this, then that means the sun has a certain amount of Planck's length inside. So there's this Planck's length, a bunch of them, that form particles here because of the negative force, right? It turns out that you can create from the length, right? This is a length, that this is a diameter. And we'll get into this here. And this is where the theory was getting so complex for me that my mind was kind of thinking in shape patterns at this point. Okay. So diameter then can do what? Create circle. It can create volume. It can create mass, so on and so forth. From the equation of pi and a diameter, you can create that. So Planck's length. Later on, the guy who looked at my work and ripped it off, Nassim Haramein, he created what's called a Planck spherical unit. So after my work, he came up with what's called a PSU, a Planck spherical unit. And that's exactly what it is. Now, in simple terms, how many Planck spherical units exist inside of that? Because if this is nothing but particles, then it's going to be filled with god-awful amount of these. The negative force, which I call the absolute zero, or 0K, 0K, which is coldness, which has no motion. So we need a space that has no motion. Because if this is pure motion here, which is heat energy, right? So it's a positive repulsive force that is exciting, it's potential, it's infinite, and it's exaggerated. So it's a force that is expansive. It has kinetic energy, it pushes, it has energy that is expansive in motion. In order to deduce the energy from this, in order for it to even exist, you would have to have a space of no motion. So we're looking at duality universe, right? So a space of no motion, also known as 0K. So we have a space of no motion, which is the negative force, and we have the positive force here. Thus, this is space, right? So the sun's in space. You have a ball of wrapped up Planck spherical units that's combusting into a sun. And what does it do? It radiates out into space. And what also does it do? It gets colder. Hotter, colder. It's all right there. All right. So, I'm just going to fast forward here. So basically, all matter can now be deduced with how many of these things are inside of matter. The deductive force is how heat motion energy radiates through space. Okay?